So, irrational numbers are, square roots that don't work out nicely. Like if you have the square root of 25, that's not irrational because we can say that's 5. The problem is when you have something like square root of 5. I don't know any number which when squared is going to give you 5. So this is just plain old irrational, right? So is the square root of 20. I don't know any number whose square root is 20. However, I know a number that goes into 20. That's a square root, right? 4. So it's kind of a good idea to know these 9, 16, 25, right? So these perfect squares, 49, 64, right? So it's a good idea to know these perfect squares. And I know that 20 is really 4 times 5. So I can write that as square root of 4 times square root of 5. But then square root of 4, I can simplify, right? We all know the square root of 4 is 2. So square root of 20 simplifies into 2 times the square root of 5. If you had something like the square root of 8, well, 4 goes into 8 as well. So I could write this as square root of 4 times square root of 2. And again, the square root of 4 is 2. I can replace that with a 2, and I can't do anything with that square root of 2. If I have something like, let's say, square root of 27, I can write that as I know 9 goes in. So that's square root of 9 times square root of 3, and the square root of 9 is 3. Right, so the whole way of simplifying irrational numbers, simplifying square roots, is to ask which perfect square goes in.